In this video, we're going to talk about the graphical representation of linear inequalities on a Cartesian plane. We already have examples on the screen, which is sketch the following on a Cartesian plane. The first example says we should sketch x is equal to 5 on a Cartesian plane. Sketching x is equal to 5. The Cartesian plane is normally drawn as something like this. Then you have your y-axis and an x-axis. There's a coordinate for the y-axis. So this is 1, 2, 3, 4. On negative side of it, we have -1, -2, -3, -4, and then lower numbers. This intersection point is referred to as 0. For the x-axis, we have 2, 3, 4, 5. And then on negative side, this will be -1, -2, -3, -4, -5. To sketch x is equal to 5 on this plane, we look for the point where x equals 5. So this is the point where x equals 5. At this point, the values for all y's are the same. So we draw a straight line through point 5. So this is it. For the second example, where we are meant to sketch x is greater than 5. X is greater than 5. Let's redraw our Cartesian plane. So this is the Cartesian plane. The y-axis. This is the x-axis. Instead of using my time to write all these numbers, let's just say this is where 0.5 falls on. So that means after 0.5 we have 6, 7, 8, 9, 10. Before 0.5 we have 4, 3, 2, 1. And then this is 0. So to draw x is greater than 5, because we have greater than here, we are going to be using a broken line through this point of x equals 5. So this is it. But we are not done. Remember, this line is the line that represents x is equal to 5. In this case, it is true that this same line still represents x is equal to 5. Now, if you notice, the line divides the plane into two parts. This side and this side. Now, we are asked to sketch the parts where x is greater than 5. So how do we know the parts that x is greater than 5? We look at the line, we go back to the line. So we pick a point after the line or before the line, whichever one we want. So if we pick any point after the line, let's say we pick this point. If we pick this point here, and this point is say 6, 0. So for the value of x that goes to 6 here. So for if x is equal to 6 in this case, x will be greater than 5. Whatever points we pick on this part of this line, x will be greater than 5. These are the points where x is greater than 5. So even if we pick here, let's say we pick here, and probably here falls between 7, 3. So on the y-axis is 3, on the x-axis is 7. The value that matters most to us from our inequality is x. So we are using the x value here. So that means 7 is still greater than 5. So whatever points we pick here, x will be greater than 5. For these points here, x is less than 5. While for the points towards the right of this line, x is greater than 5. I'll shade this part of my graph. So this is the graph of x is greater than 5. Let's do the next example so that it gets the hang of it. For the next example, we are supposed to sketch x is less than or equal to 5. Let's draw a Cartesian plane. So this is our Cartesian plane. This is our y-axis. This is our x-axis. Supposing our point of 5 falls here, So this is our point 5 and this 0. Since the inequality is less than or equal to 5, we'll be using a thick line here, not a broken line. So unlike here, because it was greater than, we use the broken line, but in this case it's less than or equal to. So anytime you have less than or equal to or greater than or equal to, use a thick line. So this is the line we use, passing through 5. Remember, this line represents x is equal to 5. And there are two sides. This line divides the plane into two sides. This side and this side. Which of the side where if you pick any points, x will be less than or equal to 5? If you notice, this side is 4, 3, 2, and then smaller numbers. So any points I pick on this side, let's say I pick this point, 4, 0, 4, 0. 4 is less than or equal to 5. So this inequality holds true. So this is the side where we'll be sketching. So my sketch will look like this. Sketch here. So this is how you plot a graph of x is less than or equal to 5. Let's take another example. For the next example, we have something similar to what we've done before. We asked to sketch y is less than 4 on the Cartesian plane. So I'd like you to pause the video and try to solve this one yourself. So like we did before, we sketch the Cartesian plane. So let's say this is the y-axis and let this be the x-axis. The important number I'm looking for is y is equal to 4. Let's assign here as 4. You can go through the trouble of giving the coordinate of each of the points. But let's say y is equal to 4 falls here. Remember, our inequality is a less than inequality, not a less than or equal to. So we'll be using a broken line here. Broken line. I'm using a broken line to do that. Now remember, this line represents y is equal to 4. So remember, this line separates this plane into two parts. So this is one of the parts, this is the other part. How do we know the part that represents y is less than 4? We simply go in and choose a point. So let's say we are picking a point around here. Pick a point around here. The y values, let's say this is 0, 3. If we use 3 here and plug into this equation, we have 3 is less than 4, which is true. So that means for points here, y is less than 4. If for points here, y is less than 4, that means for points here, y is greater than 4. The one we are looking for to shade is the y is less than 4. So you simply shade this part of our graph. So this is the shading for y is less than 4. Let's take a more complicated example. So for our next example, we are asked to sketch the region for which the set of points contain the solution set for this inequality. One of the first things you notice is that unlike before, we now have two variables. We have both the x and the y. So the first way to do this one is to rewrite this as an equality. So this is an inequality, 2x plus y less than 3. So you're writing as an equality, we have 2x plus y is equal to 3. The next thing we do from here is that we ask ourselves, when x is equal to 0, what will y be? So we can solve directly from here. When x equals to 0, y will be, we plug in our 0 plus y is equal to 3. So this is 0 plus y is equal to 3. When x is equal to 0, y is equal to 3. Another thing we want to answer is when y is equal to 0, what will x be? So we'll say this is 2. Our equation is 2x plus y is equal to 3. So this 2x plus y is 0. Plug in 0 for y is 3. So that 2x is equal to 3. And then dividing both sides by 2, x is equal to 1.5. So when x comma y is equal to, when x is 1.5, y is 0. So I have my 2 coordinate points here when x is equal to 1.5, y is equal to 0. These 2 points are going to be important because I'm going to use them to plot on the Cartesian plane. Let me clean up the space. If I have a Cartesian plane like this, let's say this is y and this is x. So on the Cartesian plane, for this inequality, know that when x is equal to 0, y is equal to 3. So when x is equal to 0 is around here, y is equal to 3 is around here. So the points we're looking for is around here. So this point is 0, 3 on our graph. For the next point, when x equals to 1.5, y is equal to 0. So let's say the point is here. So this is 1.5 for x and y is 0. The next thing is to join the 2 points with a straight line. So join these points to a straight line, we have, but remember our inequality has a less than sign, not a less than or equal to. So we're using a broken straight line. So this is this way. This straight line represents the equation of 2x plus y is equal to 3. And this straight line divides this Cartesian plane into 2 parts. This part and this part. So which part are we shading? The inequality says that we should shade the part that is 2x plus y less than 3. So how do we find that part? We can decide to pick any point here and solve for it. So let's say we pick a point here. Now, if x is 1.5 here, somewhere around here, x will be 2, right? 2, 0. So let's use 2 for the value of x inside this equation and see what we'll get. Now, since we've picked this point, notice 2 things. We are going to be looking at the inequality and the equation. So for my equation, I have 2x plus y is equal to 3. So I have 2 open brackets. At this point, x is equal to 2 and y is equal to 0. So this 0 is equal to 3. So I have 4 is equal to 3. Any value of x I pick here will be greater than this 3. So let's say I pick another point here and this point is 5, 0. If I resolve the equation, I'll have 2x. The equation is 2x plus y is equal to 3. So this will be 2 open bracket 5 plus 0 is equal to 3. So this is 10 is equal to 3. This is not equal to. From what we've seen, any point I pick towards this side of the line, the value of 2x plus y is greater than 3. That means that the opposite side of the line will have the opposing inequality sign. So that means this side is 2x plus y less than 3. You can still try to solve it yourself. Pick a value from here and plug it into the equation. Let's say 1, 0 or something. And we are asked to shade the points where 2x plus y is less than or equal to 3. So we'll be shading this part of the graph. Shading this part of the graph. Let's take another example for you to understand more. For our last example, we also have something similar. We asked to sketch the region for which the set of points contain the solution set for y is greater than or equal to 2x plus 2. So like we did before, we write out the inequality first. So this y is greater than or equal to 2x plus 2. We turn it to an equality. So this is y is equal to 2x plus 2. From here, I'll need to know the value of y when x is 0 and x when y is 0. This is to help me plot on the Cartesian plane. So I'll say when y is equal to 0, I'll immediately plug the value of y. So this 0 is equal to 2x plus 2. From here, I have 2x is equal to, moving 2 to the other side is negative 2. X is equal to minus 1. So x equals minus 1. That means when x, y, x is minus 1, when y is 0. When x is 0, what is y? So y is equal to 2, open bracket, 0 plus 2. This is equal to 2. So it is clear that when x, the second coordinate is, when x is 0, y is 2. So I have my 2 points that I used to plot on the Cartesian plane. This is our good old Cartesian plane, the x and the y-axis. Let's say this is the y-axis, this is the x-axis. So on the points where we have minus 1 for x and 0 for y is around here. So we say this point is minus 1, 0. And then on the points where we have 0 for x and 2 for y, should fall, let's give it here, 0 for x, 2 for y. If you notice, the inequality is a greater than or equal to, so we'll be using a solid line. So this is a straight solid line. Now, remember that this solid line represents the equation of y is equal to 2x plus 2. And this line separates the Cartesian coordinates into 2 parts. So this one part, this is the other part. So which of the parts represents y is greater than or equal to 2x plus 2? We can simply pick a point around here to find out. Let's say I want to pick a point here. I have picked this point. So let's say this point is 2, 0. So if this point is 2, 0, I'll try it out on my equation. My equation is saying y is equal to 2x plus 2. If I plug it in, this will be y is equal to x value is 2. So this 2 bracket 2 plus 2. The y value is 0. So this is 0. You have 0 is less than 2 times 2 is 4 plus 2, 6. So this value here is less than this value. Okay. So that means the point here is saying that the values of y here is less than or equal to 2x plus 2. If this part is less than or equal to 2x plus 2, that means this part of the line is representing x is greater than or equal to 2x plus 2. So the one we are looking for is x is greater than or equal to 2x plus 2. To shade our graph, we shade it towards this direction. So this is how we shade our inequality. So that's how to represent linear inequalities on a Cartesian plane. If this video was helpful, leave a thumbs up, smash the like button. Make sure to subscribe to the channel. It helps a lot. Thanks for watching again.